So when working with arc length and sectors, one of the shortcuts that can be introduced quite early to children is the mapping between, let's say, a fraction. We have these fraction kits, and we also have one of the things that fits in neatly with the fraction kit. Sort of looks like a circle. We don't have it here right now, and it has all the angles. Starting from 0 here, it has the 90 degrees, it has 180. So it has all the angles in it, and this is quite useful for them to just create a mapping, so that when they see, let's say, 180 degrees, it's half. And okay, so then when you place your piece, it will basically come to the angle, and they can prepare this table themselves. So if they take other pieces, so if you take a 1/3, then it will show that 1/3 is 120 degrees, and so on. So in this list, in the ones that are of course easy and they can also remember, is the 180, the 90, the 45. Then because we have 360 degrees, 1/10 is 36, same digits. When we have 1/6, the same 6 comes here, 60 degrees. And these are usually the ones that are most useful, because what you are 90, of course everyone knows. So when you have 1/4, you get 90. When you have 1/9, you get 40. So this is also something that the mapping 4 is there, 9 is there, 9 is there, 4 is there, they can remember, and 360 they can remember. 6 is already there, 6 they can remember. 1/7 and 1/5 maybe not as often used, but this is of course 36 times 2, so that's 72. So if they make a table and they memorize it, then as they go further, they'll have a lot of questions in which there are angles given. So they'll say, okay, you have a sector or you have a arc in which the internal angle is 120 degrees. Then they automatically know that for the perimeter as well as the area, we are talking about 1/3. So 1/3 of the perimeter or 1/3 of the area of the sector is what is being asked here. So if it's area, then the area of the circle, which is pi r square, and then 1/3 of that. And if you are talking about the perimeter, then 2 pi r and 1/3 of that. So this is one thing that is quite useful. Another thing that could be useful is to actually look at especially questions in which they use 22/7, they are expecting cancellation to happen. So to just map that, when you have 7 centimeter, you have a radius of 7 centimeter, then the perimeter that you are getting is 44 centimeter, okay, 2 pi r. So 2 times 22/7 times 7, right? So the approximate value is 44 centimeter. Okay. Or it is also equal to, if you're going to retain the pi, make it accurate, then it's 2 times pi times 7, which is 14 pi. So if they can remember 14 pi and 44 centimeter, then depending on the questions that are there, they usually give you multiples of this. So they'll say, okay, the radius is 14 centimeter or the radius is 21 centimeter. And then you automatically know that the perimeter then will be double, which is 88 centimeter. The perimeter here will be 3 times the perimeter 44 approximately, right? And then sometimes they will give the sector of 120 degrees with a radius of 21 centimeters, which means they're expecting you to multiply 7 by 3 times that, the main circle. They're all scaled versions. All the circles are scaled version of one circle is another way to think about it. And you want 1/3 of that. So many of these factors will just cancel out. So you will get, okay, so you have 21 centimeters, so that would have been 44 times 3, but you need the perimeter only of 1/3 of the circle, or 120 degrees, which is 1/3. So the result will stay 44 or 14 pi.